Coordinate geometry. Coordinate geometry or Cartesian geometry is the study of geometry using a coordinate system and the principles of algebra. Points are placed on the coordinate plane as shown below. The coordinate plane is a two-dimensional surface on which we can plot points, lines and curves. It has two scales called the x-axis and y-axis at right angles to each other. The plural of axis is axis. A point's location on the plane is given by two numbers, one that tells where it is on the x-axis and another which tells where it is on the y-axis. Together, they define a single unique position on the plane. So in the diagram above, the point A has an x value of 20 and a y value of 15. These are the coordinates of the point A, sometimes referred to as its rectangular coordinates. X-axis is the horizontal scale. The horizontal scale is called x-axis and is usually drawn with the 0 point in the middle. Values to the right are positive and those to the left are negative. Y-axis is the vertical scale and is also usually drawn with the 0 point in the middle. Values above the origin are positive and those below are negative. The point where the two axes cross is called the origin. When the origin is in the center of the plane, they divide it into four areas called quadrants. The first quadrant by convention is the top right, and then they go around counterclockwise. In the diagram above, they are labeled quadrant 1, 2, etc. It is conventional to label them with numerals, but we talk about them as first, second, third and fourth quadrant. The coordinate point x, y, the coordinates are written as an ordered pair. The letter P is simply the name of the point and is used to distinguish it from others. The two numbers in parentheses are the x and y coordinates of the point. The first number x specifies how far along the x-axis the point is. The second is the y coordinate and specifies how far up or down the y-axis to go. It is called an ordered pair because the order of the two numbers matters. The first is always the x-coordinate. The sign of the coordinate is important. A positive number means to go to the right x or up y. Negative numbers means to go left x or down y. Distance between 2 points. Given coordinates of 2 points, distance d between 2 points is given by d is equal to square root of dx square plus dy square, where dx is the difference between the x coordinates and dy is the difference between the y coordinates of the points. As you can see, the distance formula on the plane is derived from the Pythagorean theorem. Above formula can be written in the following way for given 2 points x1, y1 and x2, y2. D is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. Vertical and horizontal lines. If the line segment is exactly vertical or horizontal, the formula above will still work fine, but there is an easier way. For a horizontal line, its length is the difference between the x coordinates. For a vertical line, its length is the difference between the y coordinates. And the distance between the point a x, y and the origin is given by d equal to square root of x squared minus y squared. As the one point is origin with coordinate 0, 0, the formula can be simplified to this. Then find the distance between the point a 3, minus 1 and b minus 1, 2. Substituting values in the equation, we'll get d is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square is equal to square root of 16 plus 9 is equal to 5. Midpoint of a line segment. A line segment on the coordinate plane is defined by two endpoints whose coordinates are known. The midpoint of this line is exactly halfway between these endpoints, and its location can be found using the midpoint theorem, which states the x-coordinate of the midpoint is the average of the x-coordinates of the two endpoints. Likewise, the y-coordinate is the average of the y-coordinates of the endpoints. Coordinates of the midpoint m, xm, ym of the line segment AB, ax1, y1 and bx2, y2 are xm is equal to x1 plus x2 by 2 and ym is equal to y1 plus y2 by 2. Lines in coordinate geometry. In Euclidean geometry, a line is a straight curve. In coordinate geometry, lines in a Cartesian plane can be described algebraically by linear equations and linear functions. Every straight line in the plane can be represented by a first degree equation with two variables. There are several approaches commonly used in coordinate geometry. It does not matter whether we are talking about a line, ray or line segment. In all cases, any of the below methods will provide enough information to define the line exactly. The general form of the equation of a straight line is ax plus by plus c is equal to 0, where a, b and c are arbitrary constants. This form includes all other forms as special cases. For an equation in this form, the slope is minus a by b and the y-intercept is minus c by b. So the general form of the equation is x plus by plus c equal to 0. The slope is minus a by b and y-intercept is minus c by b. The point-intercept form is represented as y is equal to mx plus b, where m is the slope of the line, b is the y-intercept of the line, x is the independent variable of the function y. Using 2 points, a line is defined by 2 points a and b. By providing the coordinates of the 2 points, we can draw a line. No other line could pass through both these points, and so the line they define is unique. So it's given by y minus y1 by x minus x1 is equal to y1 minus y2 by x1 minus x2. This is the equation of a straight line passing through points p1 x1 comma y1 and p2 x2 comma y2. Let us look at an example. Find the equation of a line passing through the points a 17 comma 4 and b 9 comma 9. Substituting the values in the equation, we'll get y minus 4 by x minus 17 is equal to 4 minus 9 by 17 minus 9. So y minus 4 by x minus 17 is equal to minus 5 by 8. 8y minus 32 is equal to minus 5x plus 85. 8y plus 5x minus 117 is equal to 0. Slope intercept form is y is equal to minus 5x by 8 plus 117 by 8. Using one point and the slope. Sometimes on the gmat you will be given a point on the line and its slope, and from this information you will need to find the equation or check if this line goes through another point. You can think of the slope as the direction of the line. So once you know that a line goes through a certain point and which direction it is pointing, you have defined one unique line. In figure below, we see a line passing through the point A at 14,23. We also see that its slope is plus 2, which means it goes 2 up for every one across. With these two facts, we can establish a unique line. The equation of a straight line that passes through a point P1 x1, y1 with a slope m is y minus y1 is equal to m into x minus x1. The equation of a straight line whose x and y intercepts are a and b respectively is x by a plus y by b is equal to 1. Just look at an example. Find the equation of a line whose x-intercept is 5 and y-intercept is 2. Substituting the values in the equation x by a plus y by b is equal to 1, we'll get x by 5 plus y by 2 is equal to 1, which is 5y plus 2x minus 10 is equal to 0. Or if we want to write the equation in the slope-intercept form, we have y is equal to minus 2 by 5x plus 2. Slope of a line. The slope or gradient of a line describes its steepness, incline or grade. A higher slope value indicates a steeper incline. The slope is defined as the ratio of the rise divided by the run between 2 points on a line, or in other words, the ratio of the altitude change to the horizontal distance between any 2 points on the line. Given 2 points x1, y1 and x2, y2 on a line, the slope m of the line is m is equal to y2 minus y1 by x2 minus x1. If the equation of the line is given in the point intercept form, then y is equal to mx plus b, then m is the slope. This form of a line's equation is called the slope-intercept form because b can be interpreted as the y-intercept of the line, the y-coordinate where the line intersects the y-axis. If the equation of the line is given in the general form ax plus by plus c is equal to 0, then the slope is minus a by b and the y-intercept is minus c by b. Slope direction. The slope of a line can be positive, negative, 0 or undefined. Positive slope. Here y increases. Okay, slope. Let us look at all the slope directions. Positive slope. Here y increases as x increases. So the line slopes upwards to the right. The slope will be a positive number. The line below has a slope of this line in this diagram has a slope of about plus 0.3. It goes up about 0.3 for every step of 1 along the x-axis. For a negative slope, y decreases as x increases, so the line slopes downwards to the right. The slope will be a negative number. The line below has this line has a slope of about minus 0.3. It goes down about 0.3 for every step of 1 along the x-axis. Zero slope. Here y does not change as x increases, so the line is exactly horizontal. The slope of any horizontal line is always 0. The line below goes neither up nor down as x increases, so its slope is 0. Undefined slope. When the line is exactly vertical, it does not have a defined slope. The two x coordinates are the same, so the difference is 0. The slope calculation is then something like slope is equal to 15 by 0. When you divide anything by 0, the result has no meaning. The line above is exact, so this line here saying undefined slope is exactly vertical, so it has no defined slope.